Boom. Resume recording. All right. Hello. Good afternoon, good evening, good morning, wherever you are, and whenever you are watching this. Great to see everybody here. James, Karina, Brian, Grayson, and Karen. Thanks for holding on the fort here for a little bit at the beginning. Um, yeah, I think we're just gonna jump straight into things. There's not a lot of I guess big ideas to cover in week three. So we're gonna dive into the four notebooks that you all had to work through in the hands-on portion. I have some housekeeping items to start, and then yeah, we'll kind of work our way through. So let me go ahead and share my screen. Cool. And if we have time, we can go over either some of the Watson enrichment activity items, or we can go over some of the quiz items as well for week three, I think. Last week, reviewing the quiz for week two went over pretty well. So even though that kind of ran a little bit late on office hours, we may just do that again. I do have a hard out close to 2:30 today, or Eastern time, so we should be done as scheduled, if not a little bit earlier if we're lucky. All right. Week three. Crazy. Time flies. Almost been a whole month here, guys. Pretty exciting. So yeah, big ideas for week three that I wanted to cover. Last week was all about being hands-on with computer programming, right? So we talked a lot about like what is a computer program? How do we write code? What are the four pillars of computer programming? Your variables and data structures, which act as your nouns that store information, your conditionals and iterations or loops, which are your kind of verbs. They're the actions that happen to the data information, and then functions and classes, which are ways to optimize your code by not repeating yourself. So that was kind of the big idea for week two, and then we brought that into more specifically with Python. So these pillars of computer programming transcend Python. Every computer language under the sun will have variables and data structures, conditionals, lists, iterations, and functions. So with Python specifically, we talked a little bit about pandas and NumPy, which are kind of second tier data structures built on top of lists and dictionaries. We also talked about some other kind of nuances in Python, maybe like list comprehensions, things like that. We'll get into that a little bit down the line. And then we ended last week with taking data from an HTML page and then interacting with it using code, kind of with pandas. And I said, don't get too hung up on the syntax, especially with BeautifulSoup, because we're going to dive deeper into that in week three. So hopefully that's what you've seen in week three. We did go a lot deeper into BeautifulSoup, as well as some more complicated transformations using pandas. For module three, the idea is to practice putting those computer programming skills to work in a real use case with real world data in Python. So before we get into the modeling and the application development, the AI integrations, even interactive dashboards, we have to start by just acquiring data, cleaning it up, and preparing it for our data product creation. So that's what we do in week three. We talk about different ways of acquiring data. So in week three, we pull data from an API. So if you've already done the labs, there's a library we use called yfinance, which is just an API wrapper. So that uses an API from JSON, ingest data, turn it into a data frame. And then we also used web scraping. We actually went to yahoofinance.com and scraped the web pages, right, the HTML pages. So two different ways of doing the same thing. And I like to reiterate that a lot just because acquiring data will always come from different sources and different methods, right? You'll see kind of in some of the forum posts, I even drop some other ways. So common ways of sending data as a vendor, APIs are the most common one. HTML and websites are not as common, but are still pretty useful used. And when we get into HTML, we'll also talk about XML and files like that. And then the third way is typically just some type of file sharing. So someone will upload a file into Google Drive or Dropbox or Box, and then you have to extract that data from there. That can also be done with something known as an FTP server, a robust way if you are a if you're a data practitioner or data provider. So FTP stands for File Transfer Protocol. But basically, it's just a fancy Dropbox or a fancy Google Drive. There's nothing that crazy about it. It's just a location where you read in flat files. So With that being said, I want you to don't get caught up in the weeds of HTML. Don't get caught up in the weeds of Beautiful Soup. The big idea is data acquisition without necessarily just being handed the data on a silver platter, right? How do I go to APIs? How do I go to websites? How do I go use libraries and maybe even interact with files through FTP servers, something like that. So we're going to pull data in two different ways today. We're going to clean it and prepare it, and then we're going to make a basic visualization. Don't get too caught up on the syntax around the visualizations with Matplotlib. We're going to dive deeper into that in week 5. I think week 6. Week 6, we're going to be doing a lot of visualizations. There was a good discussion though early in the forum about like why are we using Matplotlib when way better visualization tools exist like Tableau, Power BI. Even as we'll get to in this class, we're going to talk about Plotly and Dash, which are open source solutions for interact dashboarding. Long story short, there, Tableau, Power BI, those technologies that I mentioned, you have to pay for them. There's a free tier for Tableau, but it's kind of funky, and Power BI, I don't even think has a free tier. So just being able to use open source free tools to make really cool data applications and data dashboards, that's what we're going to get into in the second half of the boot camp, this in the next few weeks here. But yeah, Matplotlib, as we talked, as you'll see too, is just a really great way of creating a quick and easy dirty notebook, dirty visualization within the notebook itself. So it allows us to quickly identify patterns using visuals, but maybe is not what I would use to give to my boss right at the end of the day. If for a less technical stakeholder, they will probably still use interactive dashboarding tools like that Tableau Power BI. But so that's the big idea for week 3. We're going to do an end-to-end extract data, clean it up, and visualize it. This is what we call a pipeline or a workflow. I think there was a good discussion that Karen was bringing up about what is a pipeline right before I started the recording. And the pipeline is exactly what it sounds like. It's a step-by-step recipe or instructions that's reproducible and that can be automated. So a very common workflow, something called an ETL pipeline. Oh yeah, and feel free to drop questions in the chat. So if you have anything to supplement what I'm ranting about, or I know I never give anyone time to breathe, just drop it in chat. And Karen, that's where she's in here for. But yeah, ETL. Let me see if I can find an example of what this looks like. Yeah, here you go. This is kind of an example of a pipeline. We have a data source. This could be your website, your API, your FTP server, your Google Drive. How do we extract the information? How do we clean it up and transform it? And then how do we load it up into a database? This is actually what we're going to do in week 4. And next week, we're going to dive into SQL. Let me just confirm that. Yes, Introduction to Databases and SQL is next week. So that's going to be our last missing step of our ETL. And it's actually funny because a database can actually also be a data source. You may be pulling from someone else's database, extract, transform, load, then clean it up. And so this is just one part of a data like workflow or data engineering workflow. When we get into modeling, there may be additional steps that happen after we load. That's maybe something like train a model or push it out, refresh and extract on Tableau or Power BI if you know your dashboards. How do we start connecting this ETL pipeline into our final data product, whether it's a model, an AI app, a data app, or an interactive dashboard? And then, yeah, the beauty of the pipeline is that it can be scheduled to run automatically or on some type of schedule, so you don't have to worry too much about it. And that can be done with DAGs. If so, kind of, let me see if I wanted to see if they had like a good one. DAG pipeline for data modeling. Let's see if I can find one. It's kind of confusing. Yeah, I was gonna say, I think I dropped SageMaker in one of my videos. I was like, oh God, we don't need to confuse everybody too much. But yeah, this is essentially like different parts of a data pipeline, right? Like how do we like end up somewhere? And they can get very complicated very fast. I think the ETL is like the basic way to deal with one, but I want to see if I could find one with like machine learning. But I guess I can find a good visual for it. Anyway. Oh my God. Gross. This is my life right now, though. This is
Maybe,
like this is what I
maybe
do
for
as my day
example,
job.
SK learn pipeline.
No, that's yeah, we'll get into that later. I was like, this is more kind of funky. So this is actually not a bad one. So I actually like this graphic. I'm gonna drop it in. This graphic may look super overwhelming, but let's kind of break it down because I do now I'm looking at it, I think it's really interesting. So we talked about how there's different cloud providers, right? We're doing a lot of our work with the IBM cloud, but that's not one of the big ones. Instead, we have AWS, Azure, and GCP. So this is Amazon, Microsoft, and Google. They're your big cloud providers. So what this is actually showing us is a data pipeline on all example for all three clouds. So we have three pipelines here, a pipeline on AWS, a pipeline on Azure, and a pipeline on GCP. And then you don't have to get caught up on the individual technologies, but they all basically do the same thing. How do we extract data? How do we extract information from a third party, a vendor? How do we use different products like data streams or data syncs? How do we connect that data and information into a database? In this case, Redshift is a database, so is Athena, right? How do we do some ETL? How do we clean and prepare that data? And then how do we consume that data via SageMaker, which is a machine learning program? QuickSight, which is basically just a worse version of Power BI and Tableau. This is a dashboard, right? So we can see we're going from left to right. We're going from raw data sources, cleaning it up, and then outputting it into ML and dashboards. Same thing for the Azure stack. Ingest data using something called Data Factory. Drop it into your databases, maybe Databricks, maybe Synapse. How do we then consume it via machine learning and dashboarding systems, right? Power BI. Same thing for Google. How do I take my raw data sources, ingest it using things like PubSub and store STS? How do we load it into a database? And then how do we consume this information via AI and dashboarding? Looker is Google's dashboarding service. It's actually really good. I love Looker. But it's the same thing as Tableau and Power BI. A million different products for the same thing. So again, that's kind of also when I teach this class, I really, really don't want to get caught up in the weeds of individual things. Keep that 10,000 foot view. Because with that view, these are all doing the same thing. Raw data, clean and transform it, ETL, load it in some kind of database, and then beyond that, extract it again from the database, clean it up as needed, and then push it out to your data product, whether it's a machine learning model, a dashboard, or something else, right? Like a text or a Slack or an email. That's what kind of these other ones are trying to indicate. So that's a pretty common movement of data between systems. Cool. And this also goes back to like, what is a pipeline? A pipeline is all of this. This can all be one big pipeline, or maybe we break it down into smaller pipelines that are then dependent on each other. Those are the different architectures that I see with this. So again, that brings us all the way back to week three. What are we doing? We're doing a version of this. We're going to be extracting data. We're going to be cleaning it up, and then we're going to be creating some basic images. Even so, even though our week three may seem like baby steps compared to these real world pipeline tools that I have here, it's still at a 10,000 foot view, the exact same thing. And again, also why I recommend don't getting caught up in the weeds of anything specific to Beautiful Soup or even specific with JSON and APIs yet. Cool. Last thing I had is logistics, and I'll be quick on the logistics. I had a video that I put up last night. If you haven't watched it yet, I go into a lot of the logistics in more detail. But basically, I had two logistical items I wanted to cover. First, what do you do if the IBM lab environment is not cooperating? What if the kernel's dead? What if the lab doesn't work? How do you do these hands-on labs in that case? The solution that I recommend is to use something called Google Colab, which I realize now I didn't link in my message. It should be colab.research.google.com or whatever extension is. And let me drop that in. I'll drop that in Zoom chat right now. And Karen also got a message about just the different Python tools or libraries. But yeah, let me drop this link in the forums as well. Boom. I know, I was gonna say these forum post editors. Oh my God, and I've logged out. I hate the forum sometimes, but we'll let that refresh. Anyway, as we've kind of already discussed, there's more than one cloud, right, in the world. We don't have to be constricted within IBM's version of the cloud. So Google Colab is Google's open free tier way to create and run Jupyter notebooks on Google Cloud, on Google Cloud Platform. So it's actually how I love Google Cloud or Google Colab. I still use it for some hobby projects. So if it should look something like this, where it should be prompting you to load in a notebook. So you have a couple of options. If you're in the lab environment, but the kernel's is not working, you can download the notebook by right-click and download. And then in Google Colab, you can upload a file. So here's one example to load in the web scraping lab that I downloaded from the course network. And then from inside Google Colab, you should be able to connect and then run the notebook as however you want. So this is also a great way if after the boot camp's over, you still want to get hands-on with some of either the content or with your own content. You can still use Google Colab forever. That's an always free tier. So here we go. This should be turned on, and then we can go ahead and run some of this stuff. I'm not sure what libraries need to be installed in Google Colab. I think BeautifulSoup's already there. But here we go. We can see if this all works. Yeah, perfect. So yeah, here we go. I'm running the notebook in Google Colab. There we go. So here we go. Print souped up prettify, and that just worked. Cool. The other way to do this, instead of uploading the notebook from the downloads, is to use my backups. As you all know, I run every single notebook every week just to make sure that whatever we give you and tell you to do actually works. So I have a GitHub location that I've linked a few times now, and you can see here are all the Module 3 notebooks that I've backed up. So we can actually open up GitHub inside of Google Colab. If I go to File, Open Notebook, I should be able to open from GitHub, and then I can either paste in the direct URL of the notebook, or I can even post in a copy in a folder. So in this case, I'm going to be copying the folder for my Module 3 notebooks. I hit Enter. Magic, it found it. And then it actually tells me the different notebooks that I have available in here. So maybe we should just do the notebook link itself. So let's say I want to go into that web scraping. If I just click that, here we go. So this would be the full URL that I want to load in. We'll copy that, and then let me see if this works. Let's use the whole notebook. Enter. Yay, that works. So this actually pulled it in from GitHub. So you can see the little logo up here is the same. This notebook is stored in GitHub. And then finally, if you want to own and control everything, Google Colab is connected to Google Drive. So you can always just upload notebooks or create notebooks inside of Google Drive and interact with them through Google Colab. So that way you own the notebooks. They're in your Google account. You can do whatever you want in there. And then yeah, finally, if you want to create a new notebook, you can go to File, New Notebook in Drive, and that'll do Jupyter Notebook inside Drive. Cool. Um, So again, long story short, if you're having issues running the labs inside of our course lab environments, that doesn't mean it should be a blocker. Utilize Google Colab, utilize my backups, and you should be good to go as a fallback. And then finally, quickly, because I want to get into the code here, the optional supplemental work. As we know, this week is a pretty light week in terms of content. It wasn't nearly as heavy in terms of videos, texts, or labs like last week. So if you want to supplement your time and effort with the course, I do have recommendations on how to do that. I am a huge fan of Kaggle. So this would be kaggle.com/learn. These have micro courses that are, again, always free for everyone. And a lot of you have already interacted with Kaggle back in week 1 when you were finding data sets. Kaggle Learn, let me sign in. You'll see that I actually practice what I preach, and I should have a few of these certificates in my account already. Yeah, here we go. I did all the machine learning, SQL, and geospatial ones, and I've started some of these other ones down here. But anyway, these are micro courses that, as you'll see, kind of go really well with the material of the course. Very common in intro to data science and machine learning workloads. There's a lot that we're going to cover in the course that are not specifically here, such as Python or Plotly and Dash, and then some of the AI concepts. But there's also a lot in these micro courses that we're not going to have time to cover in the boot camp, such as Seaborn, or like Intro to Deep Learning. I don't think we dive into neural networks much in this class. But yeah, that's kind of the balance. So to start off, intro to programming and Python. Tell me if any of this sounds familiar. Variables, functions, data types, lists, conditionals. If that doesn't sound like week two, I don't know what does. So you can work your way through the tutorials and the exercises. It should take about 2 to 3 hours per micro course. I think they overestimate some of their hours. And then same thing for Python, functions, Booleans, lists, list comprehensions, dictionaries, how to load in external libraries. If that also doesn't sound like week two and week three, I don't know what does. And then we'll get into pandas. I actually probably recommend doing the pandas one too. This is a pretty good one. More specific things about data frames. So yeah, these are all free. They should take 2 to 3 to 4 hours each. Usually they're about 2 to 3 hours. And once you work your way through them, you actually end up with a little certificate, which is kind of fun. And with your certificates, you can either upload that to LinkedIn, upload into the forums if you want. But they're kind of nice little, put it in your GitHub. Nice little way to supplement your professional portfolio that you were able to accomplish some of these things. So I used to offer like extra credit if you did the certificate and send it to me or Karen, but I actually couldn't figure out how to upload files in the forums. So if you know how to upload files in the forums, let me know. Otherwise, just tell me you did it, and I'll trust you. And we'll just make sure that your quizzes and final capstones are all good on the grade wise.
Choose files at the bottom.
Yeah, I couldn't figure it out. I feel like I had to upload it to a different part of the system, and I'm like, this is gross. I don't want to deal with it.
Oh no. Oh, no, no, no. It just makes you go through a little bit of layer of stuff.
Yep. Cool. Again, Kaggle learn, you shouldn't think that you have to do it every single week, but especially for slower weeks, or if you want to double down on some of the like extra practice on the syntax, then I highly recommend it. And if we look through kind of where we're going to be going here, programming Python pandas, that's pretty good with weeks 1 through 3. The two SQL ones are pretty good for weeks 4 and some for week 5. And then week 5 will be also more SQL and then visualization, so data visualization. And then when we get into week 7 and 8, that'll be machine learning. So we have intro and intermediate machine learning, which line up with week 7 and 8 respectively. And then to end, we have our dashboard and capstone, and we'll touch on things like neural networks and AI tools. But yeah, I think that's most of it. Programming Python pandas weeks 1 through 3, SQL week 4 and 5, data visualization week 5 and 6, and then we'll get into the machine learning ones as well. So cool. Any questions around logistics about Google Colab, Kaggle Learn, or kind of the big ideas of data pipelines, ETL, and kind of what we're doing in week 3? Let me check the chat too if there's anything crazy in the chat to call out. Yeah, apparently you can also use Python and Excel now, which is kind of fun. I'm like, doesn't this defeat the purpose of Excel? I was like, what? Just use Python. Like, what? So anyway, this is kind of funny. I thought this was like a big push by Microsoft. But yeah, I think you can also run Python inside of Power BI now as well. And my quick 2 cents on this, with Power BI and Tableau and kind of where people run into. There's actually a good call out. Sorry, there's a little bit of a side quest. Let's say you are kind of a business analyst and you mostly work within BI tools like Tableau, Power BI, Looker, QuickSight. Those are all just examples of a business intelligence dashboarding tool. That kind of limits your ability to be able to create data products. You're only being able to create these dashboards using these drag and drop tools. So the dependency that those business analysts usually have is that they expect the data to be clean and ready for visualization before it reaches them. And so then you have to go talk to the data engineer, the data scientist to make sure that they have the data all cleaned and ready to go. And that can be a bit of a problem. So these other ways, like let's say you can dabble in Python, you know a little bit of SQL. These tools allow you to actually do that data engineering within their Power BI platform. But what ends up happening is that this makes a lot of data engineers very upset because this is almost what we call hidden or like black box like engineering workloads. These are like transformations that you're doing that regular people, the data engineering team, doesn't have access to see, right? So this is why we highly recommend moving as many data transforming systems to the left so that all the dashboarding tools like Power BI, they just have to do a select star to bring in all the data as is. But anyway, this is also why you have products now like Tableau Prep, which is basically low code data transformation tool inside of Tableau to allow you to clean and prep data before it gets visualized, which is really interesting. And also why you see a big push now in the software as a service realm for tools like Alteryx, which again is low code data transformation software. Same thing as Matillion, right? Low code data transformation software. Does this look familiar? It should, because it's a data pipeline. Get data, clean it up, push it out somewhere. All the same thing at the end of the day. But again, this is why we, as the industry has evolved, we like just doing this in Python and learning it how to code because now you're not locked into a vendor. You have more flexibility. You have more custom ways of doing these transformations. You're not restricted by any of the low code, I guess, guardrails that some of these external systems put in place. As well as that, it allows you to synthesize as one team. You're not having any hidden transformations occurring within the BI software itself. Everything is being defined in the overall architecture of your data ecosystem, which is something that say a lot to clients. All right, let's dive into some code. 45 minutes, and then we'll do office hours. Cool. So I had four notebooks to go through today. We'll start with our warm up, which is just going to be the intro to web scraping. That's going to be our 3.2 lab here. So cool. Update lab. Why not? We'll see what this looks like. Again, this is what I was saying. Like, if the lab environment ever like throws issues, how to use Google Colab as a backup. So for this warm-up activity, we're getting a deep dive into the BeautifulSoup library. Just while this is loading, is known as a markdown language because there are multiple ways of writing markdown data sets. So HTML, in case you've ever Googled it, it stands for Hypertext Markup Language. And what's key there is that markup language indicator. Besides HTML, other markup languages include things like XML, which stands for Extensible Markup Language. And I think there's a couple other ones that are kind of that you see sometimes that are more esoteric. But XML, hopefully you may have seen an XML file before. I still get data sets from data vendors written in XML, which is kind of crazy. But this is like a worse version of a CSV to me. You have these tags that contain the data and information beyond it. So, for example, here is the building Surrey that is located at this address in Canada, and here's the information we have. So, how would you extract information if this is how your vendor gave it to you? You'd be kind of overwhelmed, right? Like that's not just like a normal CSV. So same thing with HTML. So Beautiful Soup is a parser for markdown languages. While it can parse HTML really well, it can also parse XML and other kind of those files. I'm pretty sure TL, a markup language. I may not. I think I'm confusing T. I don't think it is TML. But anyway, you'll see like other kind of these lines out there. I'll have to find some of the other ones. But cool. So we're gonna do a deep dive into Beautiful Soup, and again, just for this example, while we are doing it with a with HTML, note that this should transcend HTML and go into XML or anything else like it. So we're gonna breeze through the warm up so we can get into some of the real pipelines here. And if I remember too, I don't think that was too much that you actually had to code out yourself. Oh, there we go. But there's a couple here. Cool. All right, so that should all be installed, and we'll get into it. I believe in you, Colonel. The thing I like about Google Colab. So what's going on here behind the scenes when you run these notebooks? Everything has to run on a computer somewhere, right? So on the cloud, we call those computers virtual machines. So on this IBM cloud, the computer or kernel that this notebook's connected to doesn't seem to come with very many base libraries installed, which is why we have to do all of these installations ourselves, right? In Google Colab, because Google knows that you are going to be running these notebooks in a data science way, the computers that the Google Colab notebooks automatically connect to have a lot of these libraries pre-installed, which is kind of fun. And don't worry, every cloud provider does this. Google Cloud has Vertex AI, which is a way for you to run these notebooks. AWS also has something called SageMaker, all of this good stuff. All right, so here is an example of what an HTML document looks like, right? So let's say it's just like an XML file. We have tags, and within those tags, we have information. And our goal is to extract that information so then we can dump it into a database or make some data product off of it. So here we go. We use the Beautiful Soup to parse the HTML. Again, there's other parsers we can use depending on the markup language itself. And we can look at the prettify. So essentially what happens and why I like to think of it as beautiful soup, it basically melts the document down into kind of its relevant tags. So we're able to find the different pieces of information by the tag that it's contained in. And you'll also, so it's kind of like alphabet soup, right? You're looking at your bowl of soup and there's all these letters. That's kind of like all the tags of information kind of just floating around in your bowl. And I wanted to scoop up the vowels or scoop up the letter C or something. I just want to find the letter P. Anyway, that's kind of my personal analogy for it. I used to always name like my soups like minestrone or something as my variable name too back in the day. But now I just do soup as I'm a boring coder now. Anyway, here's kind of an example of extracting information from that tag. In my bowl of soup, I want to find the first and only, in this case, title tag. And when I do that, I can find the tag. And if I can get the information off of it, all I need to do is call soup.title.text. And that should bring me back the information, the text inside of the title. And again, we can see this is a tag. Same thing here. In this case, we're finding the first H3 element. For those looking astute in my document, you'll notice that I have multiple H3s. And when we just call the soup dot notation, by definition, it only pulls the first one. Again, that's just weird syntax things that you eventually kind of remember. So in this case, notice that we have LeBron James as the only tag that we brought back. And again, same thing. I have my bowl of soup. I'm looking for an H3, and I'm only going to spoon up the first one that I find. Um, As we've also kind of mentioned, the way that this is melted, it does keep intact some of the structure. So if we want to go up or down in our tree, we can do parent or child or sibling. So essentially what we're looking at here is we found this B tag, right? I've spooned up my first B element, and my first B element is this guy right here. But again, looking at this B element is inside of another tag, that H3 tag. So that's known as a parent. We have a nested tag structure. B is inside of H3 and H3 is inside of body. So if we go down here, we can exactly see what we're doing. Given my B tag, let's now grab its parent and we get back the H3. And if we do this one more time, actually, I'm just gonna do soup.find. I'm gonna soup.b.parent.parent. And this should bring back the body. So again, what did we do here? We found the first B element. There it is. We grabbed its parent, which is this H3, and then we grabbed its parent, which is the body. And if I grabbed its parent, it would be this HTML opening tag, which we again can just add in here for completeness. Assuming my notebook wants to work. Yeah, there we go. Dot parent. Boom. And we pull back the HTML tag. Cool. We'll skip over siblings, but it's the same idea. Let's find kind of the next tag that's closest to me. So we want to find the salary of Steph Curry using the object sibling 2 and the property next sibling. I didn't see what sibling 2 was. Well, I guess they pulled that from sibling 1. So again, kind of how this works is if we look at what the sibling 2 is, sibling 2 is going to be this p tag. Yeah, so I think that's kind of how it's doing. It's just finding the next item in the tree for it. Again, don't get caught up in the syntax for this. Big idea though, we melt the tags, we find the first one, and then we can find its parent, child, and siblings as needed within the tree. This is important, the HTML attributes. So let's cover these. Why is this still not working? I hate this IBM environment sometimes. What are we doing here, guys? My God. Refresh the page. Anyway, for the attributes, as we noticed, when we have our rundown of our information, it's not just the text itself. We can also grab what's known as attributes. So for HTML specifically, if I'm looking at this guy right here, we see it has an attribute of ID. And then just for showing that this is really how things work in the real world, on this Kaggle page, if I look at its underlying HTML, which fun fact you can do for any website just by right-clicking and opening up Inspect or Developer Tools, I can see that this guy right here, this is a div element, but it has all of these attributes, data test ID and class. Some of these other ones, let's see, we have an A tag here that has an attribute of href as well as role and class and things. So sometimes there's good information in those attributes. And so BeautifulSoup allows us to extract that information by referencing the attribute names. So in this case, I'm grabbing the ID attribute out of the tag child, and we can see the value of that ID should be boldest. And we can even see all of the attributes. So here it's parsed as a dictionary, ID as the key and boldest as the value. And again, what this is referencing is this guy right here. This attribute is the ID attribute, and its value is boldest. Maybe it's just how I'm executing these cells that my like cursor is not following. Cool. I don't care about navigable strings and then filters. This is important. So as we mentioned, all the with BeautifulSoup, if we just reference the tag like .b or .h3, it just pulls the first element. And that's not really what we want. Usually we want to find all elements that match. So that's where the find all function comes into play. This will find all elements in my soup that are TRs. So instead of just spooning up the first one, I'm doing that little game where I'm spooning up all the like letter Qs in my alphabet soup. So same idea here. We're spooning up all the TR elements within my tree. And here we found 4 items. 1, 2, 3, and 4. And then we can run loops on it if we want to. For each item that I found, print out this information. And same thing here. And then just like anything else, we can also find not just by tag, we can also find by attributes. So now we have like a real filter. Find all elements on my markdown document that contain the attribute ID with a value of flight. And in this case, we only found one thing. So same thing here, find all elements with the attribute href that has a value of wikipedia.org Florida. And here we found 2 of these values. So kind of interesting. Let's do this one. Use the soup object, find the element with the ID boldest. Soup.find all. I want to find all elements where I like to do quotes for things, but I like where ID is equal to boldest. Let's see if this works with that extra set of quotes. It doesn't like my extra quotes. So we'll just do ID equals boldest. There we go. And here's the one that we found. LeBron James is the only element that has this attribute. And notice I don't care that it's a B tag. I haven't said to find B tags. I only want to find this. Um, Usually though, you do care about the tags. So if I wanted to find all B tags with an attribute of boldest, I would do soup dot find all. I want to find all B tags. And then I would also want, can I just put it into a dictionary? Usually I would then do this, something like this. ID boldest. Let me see if this works first. I hate look at me live coding. See if that works. Oh my God, it did work. So you can see the first item that I'll drop this in chat. The first thing that I have in my find is the tag, and the second is the attribute. So this is usually how I would find things because we usually do care about the actual element tag in my soup as well. Cool. And I think that's all I wanted to go through here because the find function is useless. It's not useless, but it's not used very often. The find table just does the same thing as the dot notation. It just always brings back the first item. And again, usually we want all the items, so we do find all.
Yeah,
And then finally, oh, sorry, go ahead, Karen.
no, no, you finish.
Yeah, I'm almost done here.
I was,
So the last thing on here before I jump to the next notebook is just how do we get HTML from a real web page? And to do that, we use the requests library. We make a request, which basically is like opening up a new tab in your browser. We fetch the URL and then we extract the text from it. That's going to be the HTML data. And I'm just going to print the first 500 characters just to prove that this worked. And again, this is just an old snapshot of a URL. So we're going to Web Archive. That's why this is taking so long. Go ahead, Karen. You said you had
yeah,
something
I
to
was
add on.
gonna say, just there's just one little gotcha when you're looking for attributes that people might not notice right away and get stuck on. A lot of times in a web page in the HTML, IDs will always be unique, but then you often have classes. You'll have a class equals, something. And so if you want to look on class, you just have to keep in mind that Python has a keyword class, so therefore you have to do class underscore equals.
It's sort of like, again, like getting bogged down in the syntax of when to use quotes versus
That's
when not
that's
to.
the one big thing on that.
Yeah. Looks like this did eventually load. So let's see if we can get it to work on my computer over here. No, I think it's taken forever. Yeah, it's still loading on my tab, actually. So, yeah, this is kind of a bad URL to be referencing here, but it's kind of we'll introduce kind of the next notebook I want to get into. And then yeah, we'll get into it in the next notebook, but once you have the HTML, especially if it uses the table element, it becomes pretty straightforward to read that element into a pandas data frame. So in this case, what we're doing is we're actually manually extracting all the information out of each row and then making a data frame. Or what I recommend, just use the read HTML function, which will take whatever HTML string that you have and extract the table from it for you. So I unfortunately, we can see if this works. Here we go. Boom, boom, boom. Yeah, there we go. Cool. So we found 26 tables. And for this example here, we're going to manually be looping through the Markdown language, the Markdown HTML, find all TRs. For each TR, find all of the individual cells, and then for each cell, extract all the information and shove it into a data frame. When the other option is cast it as a string and then shove it into read HTML. This is honestly a little bit crazy. What I would do here if I was writing this would be something like much simpler. Tables, they wanted tables bracket 5. If I just did the dot text for that, that'll pull it out as a string. So we can see if that works. Oh, it didn't work. Maybe we can just give it the table 5. Nope. All right, maybe you do have to do it something complicated like that. That's what I get trying to live code again. Also, yeah, yeah, debugging issues live. We can do that later. Cool. Big ideas here. Um, Things I want you to take away from Beautiful Soup. First, how is data given to us? Data can be given to us in many different ways, including markdown languages. Markdown languages include HTML and XML. Again, our goal is to extract information out of those files, turn them into computer programming structures like lists and dictionaries, and then eventually clean them up using pandas structures like data frames, and then write it out to a database or notebook somewhere or visualization. With Beautiful Soup, that allows us to extract information from markdown languages. In this example, we reviewed how to extract specific information using the find all function, as well as with tags and attributes. And then we also discussed how we can then pull out specific tables and use that to create our pandas data frames. All right, let's get into the meat and potatoes here. I want to start with this real notebook. Again, luckily our notebooks are pretty short. I think we're still on target here. Cool. All right, so now let's take this into our real world problem, which is I want to extract data from Yahoo Finance on specific stock prices. So I want to know, for example, the stocks of Netflix or Apple or Tesla or GameStop, I think we'll do as well. So let's look at what we're doing. Here, it's always good to links up. So this is a snapshot of the Yahoo Finance from July 2nd of what year? I think last year, maybe 2021. So I guess through 2021, just to keep it as a snapshot. So if I look at this page, it looks like we have a lot of different tables here. And it's actually really interesting. If I creep on the underlying HTML, so again, right click, inspect, and I actually want to look at this thing right here. Let's just this June 1st thing. Yeah, here we go. We can see that this is a table. If I zoom closely, it says this is a table HTML element. And inside this table element, I have my column headers, my data body, and a footer for the table as well. So we want to extract all the information from this HTML table object. So that's our goal here. So again, it's always good to know your goal before you start diving into the code. So the first thing we're going to do is we're going to grab the HTML from the web page. And again, I'm going to do data 0:500 here. So what this is doing, this is making the request, grabbing the response, which is the web page itself, and then instead of rendering it, we're going to just print the first 500 characters just to prove that we pulled some of the HTML. Next, given that we have the HTML, now we're going to melt it down into our big bowl of beautiful soup, if you will. And then from there, we're going to try and create a data frame. So the first way that we're going to do this is what I call the manual way. We're going to loop through the HTML and we're going to explicitly extract every bit of information. And so let's actually I'm going to pull up my inspector as we go here, just so we can see exactly kind of what we're doing. So again, here is my beautiful little table that we found. Cool. So let's pop back over here. First thing we're going to do is we're going to find the very first T body element. The very first T body element is going to be this guy right here. Notice we could have also found it by its ID, which would probably be a little bit more robust. But anyway, the first T body is going to pull this guy right here. Then we're going to find all of the table row elements inside of that table body. So again, looking at my inspector, it's going to be pulling all of these TRs. 1, 2, 3, 4, 5, 6, 7. Now we're going to loop through them. For each row that we found within my table body, I want to find all of the TDs, all the individual cells. So we have 1, 2, 3, 4, 5, 6, 7 TDs. And then for each of my seven TDs, 1, 2, 3, 4, 5, 6, 7, we're going to say the date is the first one, which I think it is. Yep, June 1st. Open price should be the second one. Again, index one here is the second item. And yep, 504. And then high should be the third one, 536, etc., etc. So if all goes well here, our very first row should say June 1st, 504, and 536. And then we're going to do that for all of the rows that we found. And that just happened. Do you see how quick that was? That's crazy. That's the beauty of Python. That happened so fast. And when we look at what we pulled out, we do see June 1st, 504 and 536. So what I want to get across here is that this isn't magic. We are explicitly looking at this markdown text that we have, this markdown format, and we are manually going in and extracting the information out of it based on the tags and their location within the tree. And we're using for loops and variables and data types to be able to work through all of that. Speaking of data types, one thing to note is that this one did not care about data types, and things like my prices are going to be represented as text, which is not what I want. I want those to be integers at some point. But that's just something to keep in mind as a potential data cleaning next step. Cool. And as we also mentioned, the not only do we can we do this manually, but we can also use libraries to do this for us. So this is kind of fun, funky. This is doing some interesting things. So if we just give the URL to our function here, read HTML, behind the scenes, Pandas will make the request for you, grab the HTML, and try and convert every table it finds. So this is kind of fun. If I actually look at this, I can do length. What is the length of the data frame? So it only found one table. So that's good. It only found the one data frame. The other way to do this is by just melting down. I would have done soup.txt, but it's fine. What we're doing here is we're grabbing all of the HTML from my soup object and then using that to read the HTML. And then we can read it in from this here too. But we have an exercise because I'm gonna say, here's how I would really do it. Um, and let's actually do that actually. So let's walk through how I would actually do this in the real world, in this little exercise down here at the bottom. So we want to do the thing, but instead of pull text, we want to pull N. So we'll start with Booth life hacks, how I would do things. And then I guess I'll answer their questions. So first thing I would do is inspect the web page so we understand exactly what we're trying to extract. Again, if you don't know what you're trying to do, it makes writing the code or even telling ChatGPT or AI tools what to do pretty difficult. So if we look in here, we'll see that here's my table. It's got this attribute of historical prices with the attribute data test. That looks pretty good to me. I think I'm going to use that to help me find this table. So here's the first thing I would do. Let's define our URL. The URL is going to be this guy right here. We're going to define this as a string because we want to, it needs to be a string here. This obviously isn't a number. Now that we have the URL, let's make the request. Response, this is how I just usually do it. Response equals requests.get the URL. Once we have the response, we can grab the HTML by calling response.text. Note that in the above cells, they combined these commands. They just did request.get.text, but sometimes the request fails. So it's good to know kind of what is returned from the request. Again, if you're curious, we can actually print the status code. And if the status code is 200, then you know that we succeeded. So this successfully grabbed the HTML. And we can even print let me just print HTML 0 to 500 here. Oops, I don't know how to spell the word print. NT. Boom. Cool. So this worked. We have the URL. And I'll drop this in the Zoom chat as we go, just in case you wanted to follow along. I'll download this notebook as well and put it on my GitHub after class. Now that we have the HTML, let's make our soup. So maybe it'll be fun. We'll do minestrone. Minestrone equals beautiful soup, and we'll give it the HTML. And I'm also going to give it this HTML parser. We're not parsing XML, we're parsing HTML. And so that should just work as well. Now I'm hungry. Maybe that's the problem of naming my variables. Anyway, so now that we have this, let's try and find the table. So I'm actually going to be pretty specific in how I find the table. I want to find a table element with the attribute of data test historical prices. So I already talked through how to do that. Minestrone dot find. I want to only find one table, so I'm using the find function. I want to find a table, and I want that table to have the attribute of what I already forgot. Data, data test. Data test with a key with a value of historical prices. And if all goes well, this should find me my table. Oh, there it is. Look at that. So this found my table element, and it's a big table. So maybe we don't need to see all of it. So I'm gonna call it my table. What a great name. Great. And so now I want to shove this into a pandas data frame. At the end of the day, we always want to have a data frame. So pd.read HTML my table. Let's see if that just works. I swear, I guess this I do have to use that string IO package. Maybe we could just convert it to a string. Oh my God. Maybe we do have to do that string IO thing.
What did the result look like?
No, I'm breaking everything. I need this
Yeah.
string IO thing. And we're gonna do it on my table. So if all goes well here, oh my God. What do you mean it's not defined? Oh, I didn't run it. Might be. Well, let's try that again. Cool. So that did find the data frame. So hopefully we can just do bracket 0 now. Yay. And there's my data frame. Magic. So let's actually do this as one cell. So I can just put it in Zoom. Cool. So, and then we can call df.head. So the reason why I like doing it like this, I like to be very specific about what I'm finding, about what table I'm pulling from the markdown, right? I don't want to just randomly bring in every single table on the website, right? I want to be very specific on what I'm finding. This also makes the automation work better as I'm more specifically finding exactly what I want to find each time I dive into the website. So this is how I would create the data frame. So let's just walk through the ways that they have it down here in their questions. So first, what is the content of the title tag? Minestrone, that's the name of my soup. We're gonna find the title and we can just grab the text out of it. So the content of the title tag is Amazon.com. Next, we want to extract all the information here. This is the exact same code that we did up here. So let's just steal it and shove it down in here. And this should also hopefully, again, this is the manual way of doing things. We are explicitly going row by row, cell by cell, and seeing if it worked, which hopefully it does. Cool. Here's my data frame. To get the columns, we can just call dot columns. And for the open of the last row, Amazon data dot tail. That grabs the last 5 rows. And if I do tail 1, that grabs the last one. And let's grab the open column. So my last row should be 109.35. And again, we can just double check that. Uh, oh, maybe I have more. rows here. Let me just double check what this actually does look like. Amazon data dot tail. Oh yeah, we go all the way back to 2015 here. So yeah, 109.35. Cool. And again, all of this works for just up here as well. Once you have the data frame, it's the exact same thing, right? df.columns and then df.tail will give you my last 5 rows as well. So a big idea is how do we take our raw data as markdown, HTML or XML? How do we melt it down and how do we extract information with the end goal of creating a data frame? Because once we have a data frame, that's where you're going to see it's easy to do data engineering as well as make things and like visualizations and stuff like that. Advice, don't get caught up in the syntax of Beautiful Soup. Don't get caught up in the syntax of markdown languages. As we'll show in the next activity, it's the exact same 10,000 foot view logic for APIs, right? We're going to be getting data as JSON instead of markdown. And how do we extract information from those JSONs? Remember, I think we looked at the Major League Baseball API last week, and we saw that it came back as a data structure, not as a markdown language, but as JSON, right? With dictionaries and lists all thrown in there. But the problem is still the same. My data vendor gave me data in this format. How do I extract information from it and get it into a consistent structure, aka a pandas data frame, so that I can then downstream clean it up, load it up into databases, train machine learning models, shove it out into Power BI and Tableau, right? That's kind of the end goal here. All right, so we'll quickly breeze through the next one and then we'll put it all back together. So I'm going to jump into the final assignment library notebook. So the purpose of this notebook is to do the exact same thing as the web scrape, but instead of using markdown languages, we're going to use a library. That is going to essentially just be an API wrapper. Sorry, I'm trying to clear output of all cells here. Cool. So let's go install our libraries again, and let's load in our yfinance package. So while this is just running, let's actually look at what the Finance Python package does. I'm going to go to the documentation, which again, you should always do. And let's see if I can find the, I guess this is the documentation. Number one repository of the day. Oh my God. Good job, yfinance. What a big thing. Oh, here you go. The new documentation website's now live. Let's look at that instead. Cool. So yeah, behind the scenes, it's going to be referencing the Yahoo Finance API. And if you wanted to, you could write code to do that. Let me see if I can find some of the details. Here we go. Yeah, the Yahoo Finance API guide. So if you wanted to manually use their API, you totally could. But this sounds like a lot of work. Let me see. Yeah, here we go. Oh no, that's using the library. But yeah, this looks like a lot of work. So we're gonna just use the pre-built library wrapper for us instead, which is nice. Yeah, good to know, kind of read through the documentation of what it can do. Yeah, the full API is covered in the over here. So yeah, there's a lot you can do kind of with this, but behind the scenes, it's going against the API. And again, what's popular with this, because Python's open source, these libraries are open source, everything we do, we try and think is unique, but it's really not. We all have the same problems. So there's a lot of people with the same problem of how do I get data from Yahoo Finance? So that's where this library comes into play. It makes a lot of people's lives easier by get rid of dry, right? Don't repeat yourself. Why is James and Brian and Grayson all writing their own code to make an API request to Yahoo Finance and get data back? Why don't we just make it easy for everybody, have one definition for how to interact with the API, and have all of you use it? And that's kind of the beauty of a library in Python. So here we go. This is kind of what we're doing here. We're going and bringing back data from Apple. And here is a snapshot of what that looks like if you wanted to look at the JSON. But I don't know why I did that. I think this is a backup just in case. So yeah, that's fine, I guess. But we'll see that with this JSON, it's coming back as a list of lists and dictionaries. So again, you could pretend like, oh, we got Markdown. Oh, we got JSON. So given we got JSON, how do we extract information from it? And to do that, we use our dictionary notation. So in this case, we're extracting the key website. We can also look at all keys in our dictionary. And oh my God, parentheses. Here's all the keys. Let's say that we want to get and look at the price to book, whatever, Apple info, bracket quotes, and my value of this is $40. Yay. Why I personally like APIs versus and why a lot of data vendors like APIs versus other things is that APIs maintain data types. This is your big one. So HTML, XML, I kind of showed you a little bit earlier, right? That the data frame and stuff they were making, it wasn't keeping track of the data types. Everything is just read in as a string. But with an API, look at this. We got Booleans, we got integers, we got strings. And Python can immediately detect those data types from APIs when it's a little bit harder for it to do that automatically from Markdown language. And true for CSVs. CSVs can be really difficult for Python to interpret the data types for as well. So that's why APIs are used a lot. So here we go. With this library, there's also some handy dandy functions. We can see this handy dandy function is making a request to the Yahoo Finance API, bringing back the response, and then automatically returning it as a pandas data frame. Again, that's the beauty of a library. We all have the same problem. How do we get data from this source into a data frame? So this library has extrapolated that logic for us, which is great. We can see that we are already just returned a data frame, and we can do a little bit of data cleaning, popping out this column, and then that's what we did with the date type here. And then we can even make some basic plots with it. So again, this is Matplotlib. We haven't really gone over it yet. But Matplotlib works really well with pandas and in fact is built in to pandas. We can actually take a look at it. I'm going to pull up the documentation. Again, that's the other thing just to call out here too. As you're working through these notebooks and you see functions or libraries and things, they're all documented somewhere on the internet. So go ahead and try and find that documentation. What is the plot function for a data frame? I know this is a data frame. I know this is a plot function. Pandas data frame plot function. This uses matplotlib to create various kinds of graphs, right? And you should have some examples down here at the bottom, how to make a bar chart, how to make a line chart, etc. So that's what this function is trying to do behind the scenes. And yes, we've already went over this. These are not the prettiest graphs you'll ever see in the world, but that's not the point. The point is to be quick and dirty to help you visually identify patterns in your data. And looking at this, I can go, wow, stonks. I should have invested in Amazon, or this is Apple. I should have invested in Apple in 2005, right before they rolled out the first iPhone. That would have been a good decision. Why didn't I do that? So. Again, we see a real quick pattern here, just with a quick visualization. And if I run through the rest of this notebook, it's the exact same thing. We're just using a different stock. How do we get data for the AMD stock? How do we then turn it into a data frame? How do we then clean it up? And then if we wanted to, how do we visualize it as well? I'm going to visualize it just because I want to. I'm going to go all the way to the bottom of my notebook and shove this in. This would be the AMD share price data dot plot the dates column versus the open column. And we should get this nice little, much more jagged graph as well. Cool. So again, the purpose of these two notebooks, big idea. How do we interact with raw data from a data source, whether it's Markdown, HTML, XML, whether it's APIs or even an API wrapper, such as the yfinance library? How do we get to our purpose of creating a data frame from the information stored within those documents? And then once we have that data frame, how do we clean it up and visualize it as needed? So I think I have just enough time here to review the last notebook, and then we will take questions and then review the quiz questions as needed here. So bear with me just for another couple of minutes. In this notebook, it's just going to be a reiteration of what we've just done in the previous two. So there's no new information here, but it should be a pretty fun one just to run through, mostly because I references GameStop and I may have lost plenty of money in GameStop back in the day. So I really want to see the 2021, 2022 spike in it. So the purpose of this notebook is using everything we know about getting HTML and parsing HTML, plus everything we know about using APIs and API wrappers. How do we extract information from Markdown? How do we extract information from JSON? How do we create a data frame? And then how do we create visualizations off of those data frames? Again, we have some cookie cutter code that's just been given to us. So this function should make a really pretty graph. Just as a quick behind the scenes, this function utilizes Plotly, which we actually discussed at the beginning of the hour about how this creates interactive visualizations. This is a little bit nicer than Matplotlib, but they still kind of work and play nicely with each other. So for the first one, we want to use our API to extract information about Tesla. So we'll just use the Yahoo Finance ticker. And this is going to pull all information up to and including today. This is a live API. If I actually look at the tail of my data frame here, it actually will include today's date. Look at that, February 23rd, 2026. So very cool. This is live data here. In parallel, let's also see how we can use web scraping to pull this exact same data frame. Again, notice that we're creating the exact same data frame. I'm just showing you two different ways of creating it, one from an API and one from Markdown, depending on how the information is given to you from the vendor. So I've already done this notebook, so I'll just run through the cells. What are you mad about? Oh, I didn't download the, what did I do here? Oh, I can't find the right table. What's it doing? Oh, error reading the table. Gross. I found the error message. File not found. No table found with that. That's fair enough. Soup.find all table bracket one. I wonder if it's just the first table. Yeah, maybe that needs to be a zero. Nope. Let me see what my soup looks like. Or maybe we should look at the URL. I don't have time to debug. Oh, it does look different. This is not the Yahoo Finance one. This is the one that we wanted. Which table are they even trying to pull here? Quarterly data? Let me double check this. Or maybe I should just check my backup where I actually ran all of this just to double check. So whatever I did over here, it worked. So revenue.htm, is that a typo? No, that worked. And then soup. So this T totally worked for me. I wonder what's going on here. Maybe it's just a warning. No such file or directory. Table class. What do you think, Karen? I'm not sure why this is breaking on the lab.
What's
No,
wrong?
it's all right. Let's see if I can just make sure that I can find it. Yeah, all right. So there's my table. That works. So we found the second T
There
body
you
is
go.
what we needed.
Yeah.
You soup dot find all. Maybe we do T
Oh, sorry.
body.
What's the bottom? What's the bottom of the error?
It just says that it can't find the document. I think. Oh, it's because I'm not using the string IO thing. I know what our problem is. Let me go fix that. Live debugging. Look at me not using API AI though. I'm using my own raw knowledge. So here's the problem. It wasn't using the string IO thing in this package. I guess I didn't need it on my local machine when I did this locally. Let's see if that helps. Ah, magic. Look at me solving problems. Good job, Alexander. All right, cool. So here's we've parsed the table. And again, one thing to keep in mind is that even though we parsed the table, let me drop that in a Zoom chat in case you are following along. Again, this is the final assessment notebook in Python. You have to make sure to use the string IO wrapper around the text, just so that whatever pandas on this computer is able to read it correctly. And one thing to notice is that even though we have parsed it from here, we are not parsing it as the correct data type, right? It's parsing it not as a datetime and not as a integer. Contrast that to our data frame up here, where if I check the info of it, because it's coming from an API, look at that. It's already parsed because it's coming this from the API one, the library. Because APIs maintain the data types, Pandas knows this is a datetime, this is a decimal, this is an integer. When contrast that to the one from the web scraping version where it doesn't know the data types. So down here, we have to manually do the data types for us, which is kind of part of our data cleaning, which I guess they didn't do, but whatever. They just cleaned up the column names and things. If I was them, I would have also updated the data types here as well. Which I guess I should show you for completeness. Test the revenue dot as type as float. That should be able to parse it out as a decimal. Or I guess as an integer if I want it to be an integer. So that's how you can change the data type of a column in pandas. Again, we'll get more into that over the next couple of weeks here as well. Cool. So that's the Tesla example. And then they want you to do it all the same with GameStop. Again, one thing you should notice using the API, a lot easier, right? It automatically comes through as data frame. It automatically comes through with the correct data types. Our life is beautiful. Using web scraping takes a lot more work. And again, notice that we need to use the string IO package here. So let me just add that in. And then we'll wrap this string IO thing around all the string. Basically, all this string IO package is doing is cleaning up the string text so that all the libraries play nice with each other. And again, same deal. If I look at the .info of this, we're going to have the incorrect data types. So let's do some data cleaning. We're going to clean up our column names. We're going to drop some unneeded indexes. We're going to get rid of any null missing data. And then I would recommend converting revenue and date to the correct data type as well. Finally, once you have all the data sets ready to go, you should be able to make a graph. Oh yeah, this is what I was mad about. And for datetime format, this is using an old version of Pandas. I swear to God, this is using an old version of Pandas. And for datetime format equals true. Maybe we should have just converted it to a datetime. Let me just get rid of this. I'm gonna see if this works. So all I'm doing there is I'm removing that inferred data type function, and then we'll see if that helps. Magic. And again, using Plotly, notice this is interactive. It's interactive. I can zoom in and out and stuff, which is pretty cool. And then it just kind of works as I hover over it. So again, to get this to work, and my make graph function appear at the tippy top, I removed the infer datetime function. And again, the reason why I had to do that is because this is referencing different versions of the pandas library. You'll see like we're installing, updating, uninstalling different versions. So this must be referencing an older version of the pandas library or a newer version that doesn't have that parameter anymore. I think as Karen mentioned in the forums, both the UIs as well as these libraries, they change and update versions all the time. So being able to just keep up with them is its own full-time job.
Yeah,
dependency
yeah. Often,
engineers.
often they'll what is the word when they deprecate something in a library, they'll give you warning for a while. So they'll say use a particular method from that library, and it will say, well, this is deprecated, in the future it'll be removed. And then you'll have, a couple of revisions or so before they remove it, so you can change your code using it.
Exactly. Cool. So I think that's everything here. Big ideas in this notebook. Definitely work your way through it as the best you can. Don't
Mhm.
get too bogged down on the details of things, like specifically things like this, right? This is data set specific. What I mean by that is depending on the data set that you're cleaning, you'll have to do different things, right? And specifically in this case, I had to rename these columns, update the data types, all that good stuff. Depending on the data set, you may not have to do that. You may not even have to clean the columns, or you may not even have to drop the null values, right? That's very data set dependent. But we're not going to get into that nuance quite yet. Still in week three, I want you thinking big ideas. Purpose of week three, how do I get data from a source? How do I understand the type of data that I'm being given? And how do I start processing it to make it consistent in a data frame, specifically a pandas data frame? So, big idea from this, I have data given to me as markdown. I'm going to use BeautifulSoup. I'm going to melt it down. I'm going to extract the information that I want and create a data frame. My data is given to me as an API. Great. I'm going to read it in as JSON, break it down into lists and dictionaries, and convert that into a pandas data frame. Oh, my data set's been given to me as a CSV through Dropbox or an FTP server. Great. I'm going to read in that file natively, turn it into a data frame, and then do what I need to do with it. So that's big idea number one, and see how that incorporates into pipeline. Step one, get the data. Step two, process and clean the data. Step three, make a visualization. Right. So that's the second half of the workflow this week. Given that I have my consistent data structure as a pandas data frame, how do I start doing something with it to make it useful? So in this case, we created some interactive graphs with Plotly. Down here at the bottom, we created some static graphs with Matplotlib, and you can even create machine learning models or write it out to a database, whatever you want to do. That's where we're going to get deeper over the next few weeks. Week four, we're going to start working with databases. How do I push this to a database? How do I treat a database as a data source? How do I read data from it? And then we're going to get into more advanced visualizations and dashboarding strategies, and then building models off of these data sets as well. But the foundation, step one, is always getting your data from your vendor, from wherever it's located, before you can start cleaning it and doing anything with it. Cool. Any questions, Karen, that's worth calling out or anything in chat? Yeah,
I think I've got
documentation,
most of them.
terminology, right? Module in the library. No, I use those pretty interchangeably, but I know
Yeah.
technically I think there is, but I use them interchangeably.
Technically, yeah, sometimes we use things that are libraries that probably more properly frameworks too.
Yep.
Uh, but library is fine. I think
And
package
then
package usually contains often a package may contain more than one modules or one more or more libraries. That's why it's a package. Uh, but yeah, as long as we know what we're talking about it with ourselves and if we're working with others with them, then everything's happy.
yep. Last note here, web page produces HTML. Yep, exactly. APIs produce JSON. Yep. And that's always and forever. All web pages will produce HTML. All APIs will produce JSON.
No, no,
And
no,
then
no, no, not all.
well,
You still may have older APIs that will give you XML. Sometimes some
yep,
APIs you actually can specify what format you want.
yep. And then I would like to think that I would use a FTP, which is the file transfer protocol, to fetch CSVs, Excel files, things like
Yeah,
that. So
maybe.
those are the three different ways. Yeah, no, that can also serve
Yeah.
XML and things like that.
But I just know
But
I just know of APIs that will actually have a parameter not the default, but of JSON, but they'll say you can say format equals XML
yep,
because what you're doing, you want to ingest it from XML,
yep.
for example,
Actually, I
or
wonder if
some
the
things will give you
Fetch
just
API
plain
does that.
text. Like if it's just giving you a summary of a book, let's say, from an API, and you're getting, that's about a book library thing, book dictionary, book thing, and you want to get just a summary for given a title, and it will just be text, and it might put it in JSON as like text, colon, and the text, or you say, I just want the text.
There's a myth that HTML can also include JSON. That depends. Depends. I would say usually no, but sometimes how websites work behind the scenes, whenever I go, if I go to the website like MLB.com, I don't know, standings, behind what this web page is actually doing is it's making an API request to an underlying API. So I don't think maybe like this will actually work standings. Nope. But there's an API request being made behind the scenes here. And so that is coming back as JSON, and then the web page itself is parsing that JSON to create a table. And we're going to get into that when we start talking about data applications. So in that sense that yes, sometimes the JSON does live within the HTML as a response that's used to load or power the application itself because we need a
I'm
live
going to look at
API with live updating data sets to make sure that all of these web pages are consistently up to date with whatever is going on.
I'm going to make an example of this. You will get web pages that are script generated, or you might get something like the one I'm looking at example I'm looking at where all you see is choose a year to view films and it has years, but doesn't have any data yet. You won't get data until you click on one of the years, and then it pulls the data from a server, then displays a nice table. And that's a different kind of thing to deal with scraping because you have to automate the web browser basically uh, in order to simulate you clicking on the page to get the information you want.
Yep.
And
I
I'm
have
going to make an example of that. I just found this nice little page for playing with scraping, and I'm going to make an example of that and
only
post.
5 questions on the quiz, so I think I'll review it real fast. For activity one and unit two, which country is AMD situated? If we look at that, that was what? That was in the library version, I think. Or maybe it was web scraping. I think it was web scraping. AMD, Minestrone. Oh, that's Amazon. What was the AMD one? I already forgot. Netflix. Maybe it wasn't the second one. Uh, Apple. Oh, there we go. AMD. So if you're looking at this, the country that it's in is the United States. So I think you should also be able to see that in some of the outputs. So this should be United States. From activity one, what sector does AMD belong to? Again, same deal. I'm looking at this sector. It should be technology. So we'll do technology. What's the content of the title tag? That's the Amazon. Notice it wants the inside of it. It doesn't want the actual wrapper for title. So that should hopefully be Amazon. And then the column names, if we look at the column names, it should be date, open high, low close, volume, dividend, stock splits. So I guess it doesn't have stock splits. Date, open high, low, closed, volume.
It's A.
Is it M? I guess
What's
it
that?
used to be adjusted close. Maybe that's the one from the website as opposed to the stock.
All those answers are from the last part of that lab where you do the code yourself. It just
Cool.
shows that you did it.
And then what's the open of the last row of the Amazon data frame? Where's the Amazon data frame? Uh, which one's the
It's the one
Amazon
you
one? The
created.
web
One you
scraping?
created.
Netflix, Amazon. Yeah, here we go. It's the last price of the open. It's not, which one is it then? It's not this,
658, 626.
it's not 109. Is it the 626 one?
It's at the bottom. Yeah, I just remembered.
Yeah, gotcha. I think it's just because of the, oh yeah, there it is,
Right there.
656.29. Yeah. So that's the one coming from the API instead. Good call. So 656.26, close enough. I think that's actually incorrect, right? 656.29. Hmm. Anyway, I think it should be these
Oh
five.
yeah, good catch. I missed that typo. I
And
got one
also this is a
typo.
typo too, I think. All right, so let's
I got
finish.
to one typo and it said activity one when it was activity two.
Let's see if I did it right. Oh, I missed one. Which one do we miss?
Uh-oh. Uh-oh.
Uh-oh.
You can't do
Awkward.
that. These people will lose confidence.
Yeah. I
Oh
want to
no,
know which
eight.
one. Oh, we don't even know how yours did.
Which
I'll have
one?
to look to see which ones I got wrong, and we'll make
I
sure to
think
go
it was
through
the
and update
title.
it.
The title.
Is it the title attribute?
I
That's
think that
annoying.
was it.
Cool. Anyway, we'll keep an eye on this stuff because again, some of these quizzes are kind of annoying. So again, drop it in the live session chat or in the lounge if you want Karen and I to take a look. Karen already submitted some complaints on some of the quizzes already, and we're monitoring them up the stream.
I missed those typo
Yep.
that typo, but
And
26 instead dot 26 instead of 29. I
yep,
missed that, but I got
I
the
gotta,
one where it said activity one instead of activity two.
yep, I gotta hop off here in a sec. So yeah, last thing is don't worry about the quiz grades. Karen and I are going through them as well, and I'll manually change them on your end. If you do your 5 attempts and you still end up somehow not getting a 100, just kind of let us know. And also, yeah, feel free to reach out to us in the forums if there's any weird questions that you're like, I don't know what the answer for this should be, and we'll do our best to kind of help you out as long as you can take in that wait time before we respond back. Cool. Going into week four. This week four is a pretty heavy week if you've never used SQL before. If you have used SQL, it does go by pretty quick. In terms of hands-on notebooks, we have a bunch, but they go pretty quick. And again, I'll make sure they're backed up. Again, my notes is like anything else, like week two. If you already feel pretty confident in some SQL work, then don't feel like you have to go 100% for every single notebook. Just kind of review it for the big ideas and then be more hands-on for the more complex problems. Complex problems would be at the end here. I think 416 is a full workflow, just like what we did earlier, where you're reading data from a database, cleaning it up in a Pandas data frame, and then making a visualization from it or writing it back out to another database. So make sure you spend more time on like 411 and 4 through 416 versus the beginning if you already have a good foundation here. Brian, Karina, Grayson, James, thanks for sticking around an extra 7 minutes. And I will see you all next week. I'll post this recording and give this all out to y'all in a little bit.
Bye
But
bye.
appreciate the time.
Thank
Thanks,
you.
everyone.
Have a good one. Have a good one. Thank you. Thank you.
You too.
Cheers.